Okay, so section 8.4, sums of arithmetic series. This is basically yesterday's lesson. This is a part B, just that we're introducing some new notations. This is called sigma notation. So the weird looking E, that's called sigma. Okay, and that basically means to add. So whenever we put something after the sigma symbol, that means we're going to be adding this type of number, this type of expression over and over and over again. So basically, sigma is what creates our series. If I give you a bunch of numbers, we can write it in terms of sigma and add those numbers together. So again, don't get too weirded out with the notation and stuff. Right now, I'll explain everything and how we're going to find the pieces to make it look like yesterday's homework. Now, okay, so our I, this is the term in the algebraic expression. I know this may not make a lot of sense right now, but right now when we do examples, it'll make a lot more sense. But I is the term in the algebraic expression. Okay, A is our lower bound. Now our lower bound means this is where we start. So I'm going to put that right here, where to start. So this is going to be the number you start plugging in. Okay? B is our upper bound. And this is where we end, or where we stop. So where to stop. So if the bottom number, if it said I equals to 1, and then on top it has a 10, that means I'm going to start at 1, and then I'm going to plug in a 2, a 3, a 4, a 5, a 6, a 7, 8, a 9, and 10. So the A to B, if A is 5 and B is 20, then I'm going to plug in the 5th term, the 6th term, the 7th term, all the way up to the 20th term. Okay? So A and B tell you, you start here, you end here, and every integer in between has to be used. Okay? So again, if A is 3 and B is 6, you're going to plug in the 3rd, the 4th, the 5th, and the 6th value. Okay? So your A and your B tell you where to start, where to end. Your I is basically just the expression. So whatever the expression is after that sigma notation, that I that I have in parentheses, that's what we're going to be plugging into, the expression. Okay? And like I said, I know this looks kind of weird, but after all of this, the main thing you guys have to remember is that yesterday we used this formula, okay? And we're still going to use this formula today. We're just going to have to figure out our terms, our A1, our A sub n, and our n value. Okay, so our job is to figure out those little pieces. Once we figure out those little pieces, we can use that formula to find our sums. Okay? So again, still very important. This is yesterday's definition. If you didn't see the video yesterday, please watch it. Right? If you weren't here. So here we go. So I'm going to find the sum of that. Okay? Now notice, in our case, we didn't use the letter I. They always use the letter I in the theoretical definition, but usually N or X's are what they use. N, most likely, is what's going to be used. So notice we have sigma of 7n minus 1, n equals 1 to 10. The way we like to basically say it mathematically is to say we're going to sum all the terms of 7n minus 7n minus 11 from 1 to 10. Okay? So we're summing up all the terms of 7n minus 11 from n equal 1 to 10. So I got to figure out my first term, my last term, and the number of terms. So, to figure out the number of terms, so you kind of have to do side work. So I'm going to put it right here, number of terms. All right? So the number of terms n is going to be your b minus a plus 1. Okay? So to find the number of terms, you're doing b minus a plus 1. Well, b is 10 and a is 1. So n is 10 minus 1 plus 1. So that means n is equal to 10. So that's not too hard to figure out. It's just a little minor subtraction and addition, right? But we're finding out the number of terms. Now, if you're thinking, well, why did I do that? I could have told you the number of terms was 10 because there's a 10 on top. Well, that works whenever there's a 1 on the bottom. So if there's a 1 on the bottom and a 20 on top, then n is 20. If there's a 1 on the bottom and a 5 on top, then n is 5. But if there's a 3 on the bottom and a 10 on top, then n is 8. Why? Because 10 minus 3 is 7 plus 1 is 8. Okay? So whenever there's a 1 on the bottom, then n equals to the top number. Okay? But if n is different on the bottom, then we have to use this little formula. So just to kind of get used to it, let's just use a formula to begin with. Okay? So that's how you find your n value. Now I got to find my a sub 1. So find a sub 1. To find a sub 1, what you're going to do is plug in your first n value. See how it says n equals 1? That's where you're going to start. Plug in the number where they say start. So I'm going to plug a 1 into that equation. Okay? So 7 minus 11, that's negative 4. So a sub 1 is negative 4. Let me highlight these things so we don't lose track of them, okay? That way we know, like, hey, here's my information. We just figured it out. So the only piece missing, notice, I have my n for my s sub n and the n over 2. I have the n. I have my a sub 1 for my a sub 1. I need the a sub n, okay, the last term, okay? So to find the last term, I have to use the number 10, right? The number I'm supposed to stop at, the very top number. So let's find a sub n. So to find a sub n, I'm going to get the 10 value and I'm going to plug it in. 7 times 10 minus 11. Well, that's 59 because that's 70 minus 11. Okay? That means that my a sub n is 59. Now that I know those three things, I can now plug them into the formula that we used yesterday and find our answer. And that's it. That's the whole thing to doing this. It's just that the notation now looks different. Yesterday, they just gave you a sub 1, a sub n, and n equals 10, right? So you didn't have to do any calculations or figuring stuff out. When you have sigma notation, it's your responsibility to find all those pieces. So let's go ahead and do the work here. So I'm just going to rewrite the formula again. So I know n is 10, so s sub 10 is equal to 10 over 2. A sub 1 is negative 4 plus a sub n, that's 59. So I get 10 over 2, that's 5. And negative 4 plus 59, that's 55. Okay? So multiply 55 times 5. What is it? I'll put it over here on the side. So that's going to be 25. That's 27. So 275. And we're done. All right, so going on to part B. So notice in part B, I did change the variable. I didn't make it an n. I made it an I. Okay, because sometimes they'll use i's, sometimes they use n's, sometimes x's. Like I said, most of the time it's n values, but every once in a while they'll come back to the i's and the x's. So we're basically going to find the sum of the expression 10i minus 11 from starting with 1 going up to 7. Okay, so we're going to find the first term, second term, third term, fourth, fifth, sixth, and seventh term. And we're going to add them all up, but without actually finding them and doing it by hand. So, again, let's find our values. So to find n, find n. Remember, n is equal to b minus a plus 1. b is 7. a is 1 plus 1. So n is equal to 7. Now remember what I told you. If you start with 1, then n is always a number on top. So did we have to calculate it? Not really. Okay, because I told you guys that if the number on the bottom is a 1, then your n value is the top number automatically. Okay? Find a sub 1. So I got to plug in the bottom number, right? The number we're starting with. So it happens to be a 1. So it's going to be 10 times 1 minus 11. So that's going to be negative 1. So a sub 1 is negative 1. Now let's find our last term. To find a sub n, I'm going to plug in a 7 because that's my last number, right? That's where I'm supposed to stop. So 10 times 7 minus 11, this happens to be 59 again. So a sub n is 59. Now that I have those pieces, I can use the original formula that we used yesterday and find our sum. Okay, so I'm kind of highlighting the information we're going to need right there. So S sub n is equal to n over 2 times a sub 1 plus a sub n. So S sub 7, right? That's my n value. S sub 7. So I'm adding 7 terms. That's equal to 7 over 2 times a sub 1, which is negative 1, plus 59. 7 over 2, that's going to be times 58. Okay? And 58 divided by 2, that's 29. So it's 7 times 29. And 7 times 29, let's just kind of do that over here on the side. So that gives me a 63, and that's 14, so it's 203. And there you go. So we're going to start at a different point with the formula, but then we're just going to break it down into the pieces we need to plug it into the formula from yesterday. Now, for example 3, we are going to change the variable, and notice we're also starting from a different value, not from 1. So that means that you no longer can just say n is 16, because n is not 16, right? We're going to have to figure that out using the little mini formula, right? So let's go ahead and find n. Find n. So n is equal to b minus a plus 1. So that's 16 minus 4 plus 1. Well, 16 minus 4, that's 12, and 12 plus 1, that's going to be 13. So n is 13. All right? So my n value is 13. Again, it's not 16, or else I'm going to get it wrong if I put 16. If the starting number would have been a 1, then it would be a 16. Okay? But right now we got n is 13. Now, find a sub 1. Now notice, to find a sub 1, I'm not going to plug in a 1. Right? What number am I going to plug in? A 4. So 10 times 4 minus 6. And the reason why I'm plugging in a 4 is because that's the number I'm supposed to start with, right? The bottom number. So that's 40 minus 6. Yeah, 40 minus 6, so that's going to be 34. So a sub 1 is 34. Now let's find a sub n. Well, that's my last term. So for that one, I will plug in a 16. You're always going to tend to plug in the top number for this one. That one's not tricky. It's the a sub 1 that can get a little tricky. So we have 10 times 16 minus 6. What is that? That's 160 minus 6 is 154. So a sub n is 154. So again, I'm just going to highlight these things just so we know these are the numbers we're going to have to use. Notice this got a little bit more complicated, but not a lot more. And that's pretty much as difficult as these problems can get. They'll just give you a different starting point. Obviously, the formula they give you could be a little bit more complicated, but for the most part, they're not. So let's go ahead and plug this into the equation. So S sub n is equal to n over 2 times a sub 1 plus a sub n. So S sub 13, okay, is 13 over 2. A sub 1, that's 34, plus a sub n, that's 154. So that's 13 over 2 times 34 plus 154. That's going to be 188. Okay, so 188 divided by 2 is 94, so 13 times 94. So what do we get for this? 94 times 13, that's 12. That's 27, so it's 28. 4 and a 9. So that's 2, 12, 9, 10, 11, 12. So 1,222. And there we go. Questions on that one? So different starting point, which resulted in a sub 1 not plugging in a 1, right? We did that in part A and B. For part C, I'm showing you like, hey, just because it says a sub 1 doesn't mean you're plugging in a 1. You're finding its first term. And the first term can be plugging in any number. You're just finding the first one. Okay? So let me give you guys a little bit of time. I'm going to have you guys do this one on your own really fast. I'm just going to pause it. All right, so now that I gave you guys some time to try it, your answer that you should have gotten is 473. Okay, your n value, you would have gotten your 12 minus 2, right? So 12 minus 2 is 10, plus 1 is 11. To find a sub 1, you would have plugged in the 2. That gives you 12 plus 1, that's 13. So a sub 1 is 13. To find your a sub n, you would have plugged in your 12. So 6 times 12 is 72, plus 1 is 73. So a sub n is 73. Plug those three things into your original function of s sub n equal to n over 2 times the quantity a1 plus an. And just basically simplify it, right? So 73 plus 13 is 86. Half of that is 43. 43 times 11 is 473. So your answer is there. Okay? So we have one more example to do, but this one's different. Okay? This one's a little different than what we've been doing. So go ahead and write that out. And it's the only one we're doing, and then we're done. Okay? This one says find the number of terms, n, right? So how many terms did we add up together? It said we started from 11, we ended at 74 in terms of the values, and they added up to 425. Okay? So obviously, if n is 2, that means we only added up those two, 11 and 74. But that doesn't come out to 425. So there had to be more than just 2, right? So the question is how many? How many were there? So what we're going to do is still use the same formula. We're not going away from s sub n, okay? So s sub n is equal to n over 2, a sub 1 plus a sub n. And we're basically going to plug in everything that we were given. And once we do that, you're going to notice the only thing left is going to be the n on top of the 2. Because s sub n is 425. I don't know what n is, but we have to figure that out. A sub 1 is 11, and a sub n is 74. So notice there's only one variable left, just n. So that's what they want me to figure out. They made it really easy for me to see it, right? So let me go ahead and add on the right side here. So 425 equals to n over 2. That's going to be 85. Now, I can't divide 85 by 2. So what I'm going to do is I'm going to multiply both sides by 2. That way I can cancel them out. Okay? So what do I get? 850 equal to 85n. If I divide both sides by 85, what do I get? 850 divided by 85? It's just a 10, right? And there you go. It took 10 terms. That's all. So that's the end of everything you guys need to know for your homework.